Okay, the first formula I'm going to look at is the distance formula. The distance formula is a formula that when I learned it in high school, actually didn't really learn it, I was just told to memorize it. And the teacher said, here's the formula, this is how you find the distance between 2 points, and it's going to be on the next test. And it was a formula that I totally didn't understand, but once I thought about it, it made a lot of sense. And I realized I didn't really have to memorize it, because I already kind of knew it. So let's say I've got 2 coordinates. Let's say I've got one here at, let's say 2 comma negative 2. And another one here at, say, 4, I'll say 4 comma 4. And the question is how far apart are these 2 points? Well, how long is this segment between these 2 points? And the easiest way to think about it is to measure the distances that you do know how to find. And that's the horizontal distance between the 2 points and the vertical distance between the 2 points. And if you draw those in, you get a nice little right triangle. The vertical distance is 6, the horizontal distance is 2. So this diagonal distance is just the hypotenuse of that right triangle, which would be the square root of 40, which simplifies to 2 root 10. So the distance between those 2 coordinates is 2 root 10. And that's the way the distance formula works. So if we look at a more generic case, let's look at that. Okay, so we'll start with 2 coordinates. We'll call one of them x1, y1. Excuse me, y1. And we'll call the other one, put that over here, at x2, comma, y2. And the distance between them is going to be this diagonal. And if we break it down to the horizontal part and the vertical part, well, the horizontal part will have a length of x2 minus x1, and the vertical part will be y2 minus y1. And we should, in theory, put absolute values around both of these. And that's because imagine if x2 is, or x1 is bigger than x2, then that'll be a negative number. The absolute value will make it positive. However, once it gets in that formula, because to find this diagonal length, we need to square both of those, the horizontal distance and the vertical distance. And whether it was negative or positive, it's not going to matter. So the distance is going to equal the square root of x2 minus x1 squared plus y2 minus y1 squared. And it's just the Pythagorean theorem. It's this horizontal distance squared plus the vertical distance squared. Add them together and you get the hypotenuse squared, but if you square root that sum, you just get the distance straight up. And so that's the distance formula. It's not that intimidating a formula. And again, it doesn't matter whether you do x1 minus x2 or x1 minus x2 or x2 minus x1. Since you're squaring it, they'll just be opposites and it doesn't really make a difference like it did in the slope formula. Okay, next up is the equation for a circle. And the equation for a circle is really easy to derive once you know the distance formula, because it's, once you know the distance formula, it's really straightforward. So let's first, I'm going to think about a circle with radius 5. So I'll draw that guy in here. And if you think about a few points, that's the worst circle I've ever drawn. But anyway, let's think about some coordinates that will be on here. There's coordinate 5, 0 is going to be up here, over there, and up here is going to be 0, 5. Over here is going to be negative 5, 0. And here is 0, negative 5. So this is a circle with radius 5 centered at the origin. And if you think about it, there's some other points that you know that are going to be on here. 4, 3 is going to have to be on here, because that distance is going to have to be 5. Over 4, up 3, 3, 4, 5 triangle, that distance there is going to be 5. Likewise, 3, 4. 3, 4 is on there. There'll be a coordinate over here at negative 3, 4, etc. So to derive the equation for a circle, what you can do is you can think about a generic point somewhere on this circle. And I'll put one right, let me erase some of this stuff here. I'll put it right here. And I'll call this generic point x, y. and I know that the distance here is 5. So if I think about the distance formula, on this the center here is at 0, 0, the distance formula would tell me that 5 is equal to the square root of x minus 0 squared, excuse me, x minus 0 squared plus y minus 0 squared, which simplifies to 5 equals the square root of x squared plus y squared, which is often written in this form. X squared plus y squared is equal to 25. That's the more common form. Putting the x's on one side, squaring both sides to get rid of that square root, and x squared plus y squared equals 25. And really, it's just going to be, it's just the Pythagorean theorem. This length is y, this length is x. And if you look at these coordinates that are on this, all of them satisfy the equation. 4 squared plus 3 squared, well, that's 25. 0 squared plus 5 squared, 25. Negative 3 squared plus 4 squared, 25. So all these coordinates all around the circle are going to work. And even ones that we don't have here. 1 comma square root of 24 is a coordinate that will work. Okay, so the next thing I'm going to do is come up with another circle. This one I'll center at the coordinate, I'll put it here at 6 comma negative 8. And what I'll do is I'll also make the radius 5. So the circle is going to look something like this. And I can think about a generic point somewhere on the circle. I'll make that generic point x comma y. And I'll think about this distance. And this distance would be, well, the distance is 5. It's a circle with radius 5 again. So I'll say 5 is equal to the square root of the change in x, which is x minus 6 squared, plus the change in y, which is y minus negative 8, so y plus 8 squared. And that is the equation of the circle. Any coordinate that you can think of that would be on this circle will satisfy this equation. The way it's often written, though, is rearranged slightly as x minus 6 squared plus y plus 8 squared is equal to 25. And we can think about it. There'll be a point right here. Point here will be the point, well, 5 straight over would be at 11 comma negative 8. And if you plug in 11 comma negative 8, you'll get here, you get 5 squared plus 0 squared is 5. So another way of thinking about this equation is that it's the same equation we saw previously when it was centered at the origin, except there's been a shift that went on. So you studied in Algebra 2, you studied transformations, and this is just a transformation. The x minus 6 took the graph and it moved it over 6 to the right. The y plus 8 had a similar effect. It moved it down 8. So it was over 6, down 8, and this was just a shift of the graph we saw in the previous slide when it was centered at the origin. So here is a generic form of the equation of a circle with radius r, and it's a circle that's been shifted over a and over b, over a in the x direction and over b in the y direction. So it would be centered at AB and have a radius of r. Okay, the last formula is probably the easiest of all the ones in this video, and it's the midpoint formula. So let's say I've got a segment that joins two points, x1, y1, and x2, y2, and I want to find the midpoint of it. And so the one way of thinking about it, well, the midpoint is halfway along this segment. So the midpoint formula should kind of make sense. It's this. X1 plus y1 over 2 plus, and then comma y1 plus y2 over 2. And what is this? Well, this is just the average of the x's and average of the y's. Because the midpoint kind of makes sense that it should be halfway in between in the x direction, and halfway in between in the y direction. And so one way to actually prove this is to think about a triangle. If you think about the triangle here, then you could draw this over like this and this over like this if these are parallel. And it makes sense that if these are equal, then this and this would have to be equal. And how do you find something that's directly in between? That's the average. And this should be equal as well. So the y value should be right here. And that y value is going to be the average of the y value up at the top and the y value on the bottom. And likewise, the x value is going to be the average of the x value here and the x value there. So it's just the average of the x's, average of the y's. It's a pretty straightforward problem for finding the midpoint.